Hey guys, in this video I'm going to run you through all the solutions for the 2024 AQA A-Level Maths Paper 3. Every question is going to be timestamped so you can easily jump to a question or rewatch it if you need to. Hope this is helpful. Okay, so here we are at the front of the paper. Question 1 says, each of the series below shows the first four terms of a geometric series. Identify the only one of these geometric series that is convergent. So for a geometric series to be convergent, the common ratio has to be between -1 and 1. And in the third option, the common ratio is a half. So that would be that option. Then we've got a quadratic equation. It says it has only one real root. Can we find b? If it has one real root, then the discriminant must be 0. So then we'd have b squared minus 4 times 4 times 9 times 9 equals 0. I plug that in a calculator quickly. 4 times 4 times 9 is 144. That makes our, that means b squared must be 144. So b would be plus or minus 12. And then for question 3, one of the graphs shown below cannot have an equation of the form y equals a to the x, where a is strictly positive. Which of these graphs does that? Well, straight away here, we've got negative y values. So if a is a positive value, and we're just raising it to a power, it can't be negative, so it must be that one. Moving on to question 4, it says a curve's equation y equals x to the 4 plus 2 to the x. Can we find the derivative? So the first power of x is just simple, x to the 4 use the power rule. 2 to the x is a bit more unusual, but the derivative of a to the x is the natural log of a times a to the x. Meaning that for us, dy by dx would be 4x cubed plus the natural log of 2 times 2 to the x. Oh, that's the end. Question 5 now says the diagram below shows a sector of a circle, OAB. The chord AB divides the sector into a triangle and a shaded segment. And we've got the angle for the sector, and we've been given the radius. I'm just going to label the other side quickly, just to appreciate that's also a radius. Show that the area of the shaded segment is k times pi minus 3. Okay, well, to find the shaded area, we can think of it as the whole sector minus the triangle. So that would be, our area would be a half eta r squared minus a half AB sine C. That would be a half times pi on 6 times 18 squared minus a half times, it's going to be two lots of 18 again, so just another 18 squared sine of pi on 6. 18 squared, we calculate to that, is 324, and then it's going to be halved. Divide that by 2. That's 162. So we've got 18 squared, then we've got another 6 there, so it'll be 162 over 6 pi in the first term. And the second term is just going to be minus 162. Sine pi on 6, though, is another half. So divide that by another 2, we'd get 81. So minus 81. And then they want us to write it in this form. So we need a factor of pi minus 3. So if I want to just get pi, I need to take 162 over 6 away from this guy. Or as a factor out of this guy, sorry, I should say. So 162 over 6. And then we'd have a pi. And then 81 divided by 182. sorry, 162, but then times by 6. Oh, sorry, that times by 3, so times by another 2, and that would be equivalent to timesing by 6. Does in fact give us the 3, so we're there. So the k is 162 over 6. Which I really actually just does simplify, doesn't it? So let's actually simplify that. That's 27, sorry, should have done that earlier. Moving on to the next question. 6a, we've just got an integral to do, so they're all as powers of x. So if we want to use the rule, let's just take the time to write it as powers of x. So the 6x squared is fine. But if we have 5 over root x, that would be minus 5x to the minus half. Then using the power rule, that would come out to be, so 6 over 3 is 2, so we'd have 2x cubed, and then we'd have minus 5 over a half, that would be minus 10 x to the half, plus c. Then it says the gradient of the curve is given by this. Okay, well, we've just found the integral of that, which is the first part of finding the curve, so let's go back and get our answer. So 2x cubed minus 10x to the half plus c. Then what we need to do to finish off our equation for the curve is sub in this point to find plus c. So 90 equals 2 lots of 4 cubed, minus 10 lots of 4 to the power of a half, plus c. So 4 cubed is 64, times that by 2, 128, so 90 equals 128 minus 20 plus c. So then for c, we'd have 90 minus the 128, but plus the 20. That gives us minus 18. So y is 2x cubed minus 10x to the half minus 18. Okay, moving on to question 7. We've got two graphs, a quadratic and a linear line. In the picture, it says on the diagram, shade and label the region R that is satisfied by the inequalities where y is bigger than 0 and equal to 0, but smaller than our quadratic or equal to, and also satisfies x plus y is greater than or equal to 1. So that's just basically above or to the right of that straight line. So if we start with this guy, we have to be above 0, or on the x-axis, but strictly below, not strictly, below or on the quadratic. So if that would satisfy all this, but it would not, we don't want to include this because that's below 0. And then does it satisfy this? Yes, it does. It's all above or to the right of that straight line, so that's fine. Then it says, find the exact coordinates of A. A is this point of intersection here. So to find the intersection point, we just need to solve simultaneous equations. So let's write our equations out over here quickly. So we've got y equals 2 plus 3x minus 2x squared. And then we've got x plus y equals 1, I think. Yes, x plus y equals 1. Let's rearrange the second guy for y. So y would equal 1 minus x. Subbing that in to the left-hand equation, we have 1 minus x equals 2 plus 3x minus 2x squared. Now that's just a quadratic because the highest power of x is 2, and it's all nice integer powers. So let's bring the 2x squared to the left. That'd be 2x squared, bring everything to the left actually, so taking off a 3x, we'd have minus 4x, and then a minus 1. That would equal 0. To solve this, let's complete the square. So we'd have 2 lots of x squared minus 2x, and then the 1 still on the outside. is right, isn't it? Yeah. Good. And then, yeah, completing the square for the bit in the bracket now, we'd have 2x minus 1 all squared, sorry, double bracket, minus another 1, minus another 1. Okay, and now simplifying that up, so expanding it out, we'd have 2 lots of x minus 1 all squared, minus a 2 minus a 1, that gives us a minus 3. Sorry, I feel like I've made a mistake somehow. No, we're fine. Yeah, that's fine. Sorry. Continue. Right, so moving over, we'd have x minus 1 squared minus, sorry, yeah, just solving for x now. If we solve for x, we'd have 1 plus or minus the square root of 3 over 2. And then we've got two solutions because there's 2 points of intersection. So if we want the a point, it's actually the minus version of that. So x would be 1 minus the square root of 3 over 2. Sorry, that's all rooted. 3 over 2. And then y is just 1 minus that. So let's put it in a bracket just to be careful. 1 minus root 3 over 2. So the 1's go, and it's a double minus, which is why I did the bracket. So just the root 3 over 2 left for our y coordinate. And that's the end of the question. Moving on to question 8. It says the temperature theta degree centigrade of an oven T minutes after it is switched on can be modeled by the following exponential equation. K is a positive constant. Initially, the oven is at room temperature. The maximum temperature of an oven is T degrees centigrade. The temperature predicted by the model is shown by the graph. Find room temperature. So room temperature, they said, is what it's at initially. So we can find that just by setting T equal to 0. So if T equals 0, what does our model do? Theta would be 20 and 11 minus 10 e to the 0. So 11 e to the 0 is just 1, so just 11 minus 10, which is 1, so it's 20 degrees centigrade is room temperature. Cool. Then part B, find the value of T. What was T again? The maximum temperature of the oven. So we can see that's what's happening in the long run behavior as our time tends towards infinity. So if we think about our, we get our equation, let's just write it out quickly. So 20, 11 minus 10 e to the minus kt. Well, if we think about an e to the minus kt graph, that looks like this, right, guys? So that we know that e to the minus kt tends towards 0 as t tends to infinity. So that means theta would tend towards 20, 11 minus 0, which is just 20 times 11, and that would be 220 degrees centigrade. Then it says the oven reaches a temperature of 86 degrees centigrade 1 minute after it is switched on. Can we find the value of K? So whenever you get something like this, guys, where there's units going on, make sure you double check the units. In this case, it is actually written in minutes, but sometimes they like to write it in seconds just to throw you off. Sorry, and the significance of that is if they don't give you the same units as the beginning of the model, then you have to convert. But here we don't, so we just know that theta is 86 when t equals 1. So then we get to plug in, so 86 would equal 20 times 11 minus e to the minus k. Sorry, 10 e to the minus k. So solving that, first let's expand. It'll be 86 equals 220 minus 200 e to the minus k. If we rearrange for e to the minus k, it would be 220 minus the 86, and then divide that by 200. That's 67 on 100. Then we'd know minus k is the natural log of 67 on 100. So k is just minus the natural log of 67 on 100. So if we plug that in the calculator, minus, where's the natural log? Oh, here he is. Shift, fraction 67 over 100. So 0.400. The three significant figures. Find the time it takes for the temperature of the oven to be within 1 degree centigrade of its maximum. So we can just find out the time it's going to be 1 degree lower than that. So that our maximum was 220. That was the long run behavior, right? That was the maximum. So we're looking for the time it takes to get to 219. So theta is 219 degrees centigrade. What does our equation give us? So 219 would equal 20, 11 minus 10 e to the minus. I was going to keep it as k, guys. I'll plug in our result for. Actually, no, let's just use the 0.4. It's pretty accurate. So let's use that. Minus 0.4 t. If you're like worried at all, you can just store our value of k here, right, and plug it in the full decimal expansion in your answer later, but I'm just going to use the 0.4, it's going to be fine. Okay, so then we've got to rearrange. So dividing by 20, we'd have 219 over 20 equals 11 minus 10 e to the minus 0.4t. So then e to the minus 0.4t, if we maneuver that around, that's going to be 11 minus the 219 over 20. Do that first, and then divide that by 10. That'd be 1 over 200. And then just quickly solving now. So t would be minus 1 over 0.4 natural log of 1 over 200. So minus, oops, clear that, minus 1 over 0.4 natural log of 1 over 200. That'd be 13.2, let's say, ask for a rounding actually. Okay, so to three significant figures, it would just be 13.2. And that's in minutes. And that's the end of the question. Sorry guys, not sure if you saw all that. So there it is there. Okay, moving on to question 9. It says figure 1 below shows a circle. We've got the equation of the circle. Can we rewrite it in the nice usual form? So let's move it all to the left-hand side first. So x squared plus 8x plus y squared minus 12y plus 27 equals 0. So then we'd have x plus 4 all squared plus y, I'm just completing the square here by the way guys, y minus 6 all squared we'd have to take away a 16 from the 4 squared in the first bracket, and a 36 from the 6 squared in the second bracket. The 27 is still there. Tidying all that up, we have minus 16 minus 36, excuse me, plus the 27, that's minus 25. So it's x plus 4 all squared plus y minus 6 all squared equals 25. Then it says show that the coordinates, state the coordinates of P. P is the center. That would be minus 4, 6 from our form. That's right, yeah. Yeah, minus 4, 6. Find the y coordinate of Q. So Q is where we're on the y-axis. So that's where x is 0. So if we plug in x equals 0 into our form, or into this form, actually, that's the expanded form. We're going to need to expand anyway. Let's do that. Then we'd have y squared equals, because that guy and that guy go, and then equals 12y minus 27. Then bringing that to one side, it's just a quadratic, y squared minus 12y plus 27 equals 0. Factors of 27 are 9 and 3, which is convenient because that can give me a 12. So y minus 9 and y minus 3 equals 0. So y could be 9 or 3. Point Q is the higher point of the two intersection points. So we want the bigger value. So y equals 9 for Q. Okay, now they've added to the diagram. It says the line segment QR is a tangent. So immediately, you know, if we think about our circle theorems, tangents intersect or are perpendicular to the radius. So we know this angle is a right angle. So this triangle is actually a right angle triangle. PQ is a radius. So let's go back and actually check our radius. R squared was 25. So this is 5 here. And we also knew what Q was because we just worked that out in the last part. So Q was 9 or 0, 9. And then we're given the coordinates of R. That's 9 minus 3. Find the angle. Sorry. Find the angle QPR. Oh yeah, QPR. Sorry, that's this angle. Yeah. Sorry, I thought it was the right angle for a second. No. Okay, that's easy enough because if we have the 2 points Q and R, we can find this length, and then we can just have a right angle triangle. We can find that length. We can always find the distance between 2 points with Pythagoras. So we first find the length QR. So that's going to be the square root. Well, we've gone across 9, so 9 squared. And then we've gone down 12, so plus 12 squared. So square root of 9 squared plus 12 squared comes out to be 15. So this length is 15. So with a right angle triangle, we can just use SOHCAHTOA. We actually have the opposite and the adjacent. So we know tan of our angle QPR, sorry. QP, what am I doing? ER equals the opposite 15 over the adjacent 5, which is just 3. They want the answer in radians. My calculator's in radians. Good. So angle QPR. Writing the wrong thing. QPR is inverse tan of 3. So inverse tan of 3 gives us 1.25 radians to, and they want 3 significant figures this time. That actually is 3 significant figures, so we're all good. And that's the end of the question. Okay, moving on to question 10. We've got a function asks for the derivative from first principles. So first, let's write out the first principles formula. That's f dash of x is the limit as h tends to 0 of f of x plus h minus f of x all over h. And then we need to substitute into that. So that's the limit as h tends to 0. Now for f of x plus h, guys, all you have to do is plug in x plus h for our into our function wherever you see an x. That would be 5 lots of x plus h cubed plus an x plus h minus, sorry, cubed there, and then minus the whole function. So minus 5x cubed plus x. So this is going to be a little bit frustrating because we've got to expand out that whole cube bracket. So you can do that by hand, or you can do the binomial expansion quickly. That's what I'm going to do. So that would leave us with the limit as h tends to 0. We'll have a 5, then an x cubed, the first term. And we'd have 3 choose 1, which is 3 times x squared h. 3 choose 2, which is also 3 times xh squared. And then just an h cubed. Then the x plus h. Then the minus the whole bracket 5x cubed plus x. That's all over h. Now let's tidy up. Some things are going to cancel. So we'll notice we've got a 5x cubed from here, and that's going to cancel with that first term over here. So that's going to completely go there and that guy. Then we've got an x in here and a minus x from this bracket here, so those terms are also going to go. And now let's see what we've got left if we expand out. So that's going to be the limit as h tends to 0 of 15 x squared h plus 15x h squared plus 5h cubed plus h all over h. So now everything has an h, you'll notice. That's always what we're looking for, because then we can get rid of the denominator, which is why we had to do this, because we can't divide by 0. So let's cancel off the h. So h goes there. That becomes a squared. That becomes a 1. That h just goes. So then we're left with the limit as h tends to 0. That's a terrible handwriting. H tends to 0 of 15x squared plus 15xh plus h squared. Sorry, this guy should just be a 1, right, guys? H divided by h. So that's where our 1 comes from, plus 1. And then if h is tending towards 0, all the terms with an h left now just are 0, which leaves us with our final answer that we were looking for of 15x squared plus 1. Okay, now moving on to question 11. We've got a curve. It says the shaded region R lies below x, the x-axis, and is bounded by C in the x-axis. Show that the area of this curve, this region R, can be written as P plus Q ln 2. So that's just an integral, right, guys? And if we're going to integrate, we're going to need our limits first. We need to see where this guy equals 0. So first job is solve for y equals 0. That would leave us with x squared minus 8x minus the natural, sorry, times the natural log of x. That's important. And you'll notice that's can be further factorized. So x, then x minus 8, then the natural log of x equals 0. That gives us 3 solutions. So x can equal 0 from the first factor, x can equal 8 from the middle factor, and x can equal 1 from the last factor. So the guys we're after would be 1 and 8. So now we just have our job to integrate this. So the shaded region R is going to be the integral of x squared minus 8x ln x dx between 1 and 8. And this is like a classic integration by parts, guys. If you see a product of two functions, especially these guys, powers of x and natural logarithms, that's going to be a time to use integration by parts. So that you can get this in the formula booklet, but I'll just write it out here for you guys so you can follow along with what I'm doing. So it's integral of u dv dx is uv minus the integral of v du dx. Oops. Dx. And then when we do integration by parts, guys, if you see an ln x, that's always your first choice for u. Always a lot nicer to differentiate ln x than it is to integrate. So basically, always pick ln x if you're doing integration by parts, and it's there. For you guys in A-level maths, at least. Right. So, yeah, we're going to say u is ln x, which leaves us with no choice but to call dv by dx whatever's left multiplying, so that's x squared minus 8x. Then du by dx is just 1 over x. And then v, if we integrate, would be a third x cubed minus 4x squared. So plugging that in, right, yeah. So then r now is u times v, which is pretty messy, admittedly. Third x cubed minus 4x squared times ln x, evaluated from 1 to 8, minus the integral of du dx times v. That's just going to take a power of x off everything. So it's the integral from 1 to 8 of a third x squared minus 4x dx. So then doing the last integral there, we'd have r equals a third x cubed minus 4x squared ln x minus a ninth of x cubed minus 2x squared from 1 to 8. So unfortunately, that's just plugging in a load of numbers now. So r would be a third. Right, let's do a big bracket here, actually. Big bracket. That again, actually. Big bracket, small bracket, third of 8 cubed minus 4, 8 squared, ln of 8 minus a ninth of x, sorry, not x, 8. I just made a classic error, realize, guys, as well. I should have put a bracket around all this because we've got a double minus going on here and here, haven't we? So let's just fix that. That's actually a plus there. Sorry. Minus a ninth of 8 cubed, and then it's plus 2 lots of 8 squared. That's the top limit. And the bottom limit, fortunately, the natural log of 1 is 0, so we can just completely get rid of that first term. So it's minus big bracket. It's going to get a bit messy here, sorry guys. So minus big bracket, minus 1/9, and then plus a 2. Okay, so let's just use our calculator to tidy this up. So if we look at all the constant terms without the natural log bit there, or actually let's do the natural log bit first. Actually, so we have 8 cubed over 3 And then minus 4 lots of 8 squared. What does that give us? Minus 256 over 3. 256 over 3. Natural log of 8. And then the constant terms, we've got minus 1 over 9, 8 cubed. Then plus 2 lots of 8 squared. Or that's, yeah, just write 8 squared. And then we've got double minus a ninth, so that's plus 1 over 9. And then minus a 2. That's 623 over 9. That's right. All right. Yeah. It was a plus 623 over 9. Okay, and then it's not quite in the right form. They asked it in the form of ln 2. Well, you'll notice ln 8 is a ln of 2 cubed. So we can bring that 3 down and multiply this all by 3. That would be minus 256 ln 2 plus 623 over 9. Okay, moving on to question 12. We're starting the statistics section. So we've got a frequency table. It first asks us to find the interquartile range of these 84 students. So we need to find Q1. So for Q1, we can think like that's going to be the first quarter of the student. So 84 over 4, what does that give us? 84 over 4 would be the 21st value. So we've got 5 values over here, and then 18 here. So the Q1's going to live in that that third group here. So that's where the number of websites is 2. So it's going to be equal to 2. Because there's no in between any of the values to worry about here. Then Q3, we need 3/4 of the value. So that's just 21 times that by 3. That would be the 63rd value. So let's go down. So adding up the frequency as we go along, we've got 1 plus 4 plus 18 plus a 16. Let's see how far that gets us. So we're only at 39 now. So then plus the 5. And then that's 44. So we're definitely going to be in the next group of 5. If we go to 37. We're definitely, we've gone way past what we were looking for. So it's in this group here, the third quartile, and again they're all just 5 for their value. So that's going to be the third quartile. So then IQR is just 5 minus 2, which is 3. Okay, then question 13 wants us to. Sorry, the shaded region on one of the Venn diagrams below represents A union C, all intersecting B. So whenever you get the set notation, guys, you just want to do it in steps. So A union C, that would be all of this here. But then we must be in B. So highlighting everything that's in that red that's just in B is all just this, isn't it? So that's our option. Okay, and that's the end of the multiple choice. Moving on to question 14 now. It says the annual cost of energy in 2021 for each of the 350 households in village A can be modeled by a random variable X pounds. It says first, can we calculate the mean of X? So the mean of X, you want X bar, that is the sum of X over N. So that's going to be 945,000 all over n. How many households have we got? 350 households. That's £2,700. The standard deviation, that's the square root of the sum of x squared over n, sorry, not 2, minus the mean squared. So that would be square root of 2,607,500. Sorry, 607,500,000 over n, which is 350 again, minus our mean, which is stored as our answer currently, so just answer squared, which is 400. That's 400 pounds also. That's our distance, so it would still be measured in pounds. Average distance from the mean, sorry. Good. Right. So for households in Village B, the annual cost of energy in 2021 has a mean of 3,100 and a standard deviation of 325. Compare the annual cost. So, like, we've got a measure of average and a measure of spread, sort of central tendency. So, the average cost is higher. For Village B. But the variation in cost is lower. Okay, that's the end of 14. Okay, moving on to question 15. We've got a binomial distribution. So x is a random variable modeled with that binomial. The mean of a binomial is just NP. So for us, that means x bar, the mean of our random variable, is 48 times 0.175. So plugging that in the calculator. Oops, 0.175. Decimal. That's 8.4. Then the variance, so that's sigma squared. Sigma squared is given by NP1 minus P. So all I need to do is multiply my mean from before, the 8.4, by 1 minus our P value, which is 0.175. Decimal. That means the variation of x, that's the proper notation, really, I suppose. I could call it sigma x, but it's whatever. Variation of x is, or the variance of x, is 6.93. Okay, then they ask for the probability of x being less than 10. So that's the same as the probability x is less than or equal to 9, which is just a job for our CD function in our calculator. So catalog, no, what am I doing? Home, distributions, cumulative distribution, if we want all the values below 9, and including 9. Then we just want one value, so we won't use the list. So variable 9, n is 48, p is 0.175. Execute, that gives us 0.674. Then it wants the probability x is greater than or equal to 6. Well, that would be the same as, if we add up all the values, that would be 1. We don't want all the values, we just want 6 and above, so we need to remove 5 and below, so we'll subtract x is less than or equal to 5, and then again, that's just another job for my CD function here. Let's just change this guy to 5. And execute that. So it would be 1 minus 0.13248, which would be 86752, or let's call it 0.868 to 3 significant figures. Then we want 15 values between 15 and 9 inclusive. Well, if we sum all the values, so we want this. If we sum all the values up to 15, that's x less than or equal to 15. Obviously, we don't want all those values. Which values, if we include, we don't want? That would be 8 and below. So we'll just take those away now. X is less than or equal to 8. So again, a job for our CD function. So the first value we want is 15. That gives me 0.994. Let's do 0.9402. Then take away what we get when we plug in 8. That gives us minus 0.531. 53172. Plugging that in a calculator to do the subtraction. Oops. What am I doing? Calculate 0.99402. Take away 0.53172. That would be 0.4623, or we'll call it 0.462 to 3 significant figures. And that's, we've got one more bit, I think. Yeah, one more bit. So the aeroplanes used on a particular route have 48 seats. The proportion of passengers who use this route to travel for business is known to be 17.5%. So that you'll recognize those are the same numbers we had for this guy. So basically, X is number of seats used. I recommend you follow this process whenever you're modeling question. Make sure you're clear on what you're modeling, what you're counting, and then it's the same binomial we had before. So that's binomial with 48. Sorry, not seats used. It's well, I suppose we could call it seats used, but like that's a bit confusing. So number of who use the route. But it's binomially distributed with 48 seats to trial, and then a probability of 17.5%. That's 0.175 like before. Make 2 comments on whether it would be appropriate to use X to model the number of passengers on an aeroplane who are traveling for business using this route. Well, the N and the P are appropriate. But let's think about what are the assumptions that go into the binomial distribution. So first off, like your p-value should be constant. And events should be independent. So you could easily come up with some issues probably for this model then, because does it say where the route's for? Travel for business. So people often take holidays in around summertime. People have kids, so you'd imagine the probability of some of the seats being used would decrease in holiday periods. So then it's not a very good model. Then it would violate the model, but it might be a good model for parts of the year, but it just says a comment, right? So yeah, you might see P might change during holiday seasons. So depending on like the time scale you use this for, it might not be a great model the whole time. Good. Okay, moving on to question 16. There's a medical student believes that in adults there is a negative correlation between the amount of nicotine in their blood stream and their energy level. The student collected data from a random sample of 50 adults. The correlation coefficient between the amount of nicotine in their bloodstream and their energy level was found to be minus 0.45. Carry out a hypothesis test at the 2.5 significance level to determine if this sample provides evidence to support the student's belief. For n equals 50, the critical value for a one-tailed test at the 2.5% level for the population correlation coefficient is 0.2787. Okay, well, H0 is that they're not correlated. That's always what we're going to do for a correlation coefficient hypothesis test. And here we've got an example of a negative correlation. They're being specific, so it's a one-tailed test. So they think it's less than 0. And then if that's the critical value, that value is valid for both the upper tail, so positive correlation, and the critical value for the negative correlation. That would be minus 0.2787. So if we want evidence, we need something more extreme than minus 0.2787, which is what we have. So our rho is smaller than minus 0.2787. So is more extreme. Well, let's say lies in the, let's use the proper terminology, shall we? So let's say lies in the critical region. So measured PMCC lies in critical region. Therefore, evidence to reject H0 or in favor of negative correlation. Okay, moving on to question 17. It says, in 2019, the lengths of newborn babies at a clinic can be modeled by a normal distribution with a mean of 50 centimeters and a standard deviation of 4 centimeters. So mu is 50, sigma is 4. The normal distribution is represented in the diagram below. Label the values 50 and 54. Okay, so 50 is specifically the mean. And then 54 is one standard deviation away from the mean, which is an important point, like a standard point. So it's where the point of inflection is. So it's here, where it just starts to, but you can see it's sloping down and then start sloping up, and it's about there. So that's 50 and 54. Show that the probability that the length of a newborn baby is less, state the probability that the length of a newborn baby is less than 50 centimeters. So that's just everything left of the mean. It's a symmetric distribution, so that's just a half. Find the probability that the length of a newborn baby is more than 56. So that's the probability, that's define a random variable. Say L, normally distributed with a mean of 50 and a sigma of 4, so 4 squared. And we're asking the probability L is greater than 56. That's a question for our CD function for the normal. So normal CD, the lower would be 56, and then we'd want to add all the probability all the way up to infinity, so I'm just going to plug in a big number. And the mean is 50, standard deviation is 4, execute that. That's got a probability of 0.0668. Find the probability that the length of a newborn baby is more than 40 centimeters, but less than 60 centimeters. That's the probability that L is between 40 and 60. Yeah, so that's again a question for our CD. We just have to change our lower and upper. So 40 and then 60. Oops, we're done 40 again. There we go. And then scroll down, execute. That's 0.987. That's to be expected. That's a big wide thing across the mean where all our probability is, all that area is. So 0.98, let's call it 988. The three significant figures. Okay, then part E, determine the length exceeded by 95% of all newborn babies. So basically, in other words, it's like we're thinking, where's the bottom 5%? If that's 5%, we want to know what that value is. So that's a job for the inverse normal distribution. So we'll go to our inverse normal now. I'll scroll a bit further down. So the area, the probability, if it's the bottom 5%, that's a probability of 5%. So 0.05. And it's got our mean and sigma from there from before. So just execute that. That would be 43.4. And that's measured in what? Centimeters. Yeah, if it's the bottom 5%, 95% of babies exceed 43.4 centimeters. Okay. Then part F, it says, in 2020, the lengths of 40 newborn babies, so n equals 40, at the clinic were selected at random. The total length of the newborn babies was 2060. So the sum of x was 2060. So that means our x bar, the average of these babies, is 2060 over 40. So let's evaluate that. What am I doing? There we go. 2060 over 40, which as a decimal is 51.5. And then it says carry out a hypothesis test at the 10% significance level to investigate whether the mean length of the newborn baby at the clinic has increased. So that's a one-tailed test, right, guys? So H0 would be assuming the mean has not changed at all. So the mean we had before, which was 50 centimeters, and then the test hypothesis is that mu is greater than 50 centimeters. And it says you may assume that the length of a newborn baby is still normally distributed with a standard deviation of 4 centimeters. So, oops, close down my iPad. Up again. Okay. So, first off, our distribution from before was a normal distribution with a mean of 50 and a standard deviation of 4. We've got a test statistic which is about the mean of a sample. So we need to get the sample distribution, yeah, for a sample of size 40. So if you remember, the mean, the sample distribution, so the distribution for the mean of a sample of a certain size, if you have a normal distribution, you take it's the same mean, so it's still just 50, but you have to do you have to divide your sigma squared by n. And what I like to do is I write the square root of sigma squared, so that's the 4 squared over 40, and then that squared, right? Because just to be clear here, so the sigma for x bar is the old, the sigma squared for x bar is the old sigma squared over n, but then you have to square root that if you want the standard deviation, right? So I like to write the square root so I don't get confused with what's what. Let's actually work out what that is then. So the square root of 4 squared over 40 is root 10 over 5. Let's put that as a decimal. So 0.632, let's call it. So that means our sampling distribution for a sample of size 40 is 50 with 0.632 squared. And then now we just have to check what the probability of our test statistic is. So we need to find the probability x bar is greater than 51.5. So if we do that with our new distribution here, so that's again a job for our normal CD. So now it's a lower of 51.5. The upper just goes up to a big number. We want to add up all the probability. The mean is still 50, so that's fine. But our standard deviation now is 0.632. Execute that. That's 8.81 times 10 to the minus 3. So that's 0.0081, which is much smaller than 0.1, the 10% significance level we needed. So therefore, evidence to reject H0 and mu has evidence in favor of or a higher mean and in favor of mu being greater than 50. Moving on to question 17. Sorry, question 18. Says the human resources director in a company is investigating the graduate status and salaries of its employees. G is the event where the employee is a graduate. H is the event where they earn at least or over £40,000 every year. And then the findings are summarized below. So it's just a table of probabilities. And then the first thing says, can we find the probability of G? So there's two ways we can have G. Like G can happen when H does or doesn't happen. So we just sum these two guys. So the probability of G equals 0.21 plus 0.18. That would be 0.39. So then it says find the complement, the probability of the complement of G intersection H. So G intersection H is this guy, which means the complement is just all the other probabilities. So the probability of G intersection H complement would be 0.18 plus 0.07 plus 0.54, which is 0.25 plus that, which is 0.79. Then probability of H given the complement of G. So I recommend, we could probably get away with not doing it, but to be honest, just to be really consistent, I recommend whenever you have a conditional probability question, you just use Bayes' theorem, and then you really can't go wrong. So the formula, which is in the formula booklet, would tell you this: the probability of H and G complement over the probability of G complement. So H and not G. So H and not G would be this guy. So 0.07. over the complement of G. So that's these two guys, which would be 0.07 plus that, which is not, let's just write it out, 0.07 plus 0.54. If we write that out, what am I doing? Doing the wrong. Home, calculate 0.07 over 0.07 plus 0.54 is 7 over 61, or as a decimal, that is 0.115. Determine whether the events G and H are independent. So we'd have to check if probability of G times the probability of H equals the probability of G intersection H. So that's what independence means. So first let's do the left-hand side, probability of G times the probability of H. Probability of G we already worked out, that was 0.39. Times that by the probability of H, which is just 0.28. Times 0.28, what does that give us? Decimal 0.1092. And the probability of G intersection H, so G and H, is 0.21. So not equal, therefore not independent. Okay, moving on to question 19. It is known that 80% of all diesel cars registered in 2017 had a carbon monoxide emissions less than 0.3 grams per kilometer. Talat decides to investigate whether the proportion of diesel cars registered in 2022 with CO carbon monoxide emissions has changed. So that's a two-tailed hypothesis test. He hasn't commented whether it's bigger or smaller. It's just not the same. So suitable null and alternative hypothesis. So that would be H0, where P is 0.8, and H1 is just a change, so P is not equal to 0.8. It says use a 10% level of significance to find the critical region for Talat's test. So let's just first decide what we're counting. So X is the number of cars where emissions is less than 0.3 grams. Sorry, where emissions equals. No, sorry, less than, I was right. Less than 0.3 grams per kilometer. And we need to use a binomial then. That's a yes, no, whether they satisfy that. And he took a sample of how many 25 diesel cars in 2022. And the null hypothesis is that it's 0.8 is the proportion of cars. And then we define a critical region for the two-tailed test. So that means we're doing a 5% per tail. And then the average of this is, if we do 25 times 0.8, 20. So that's roughly where like the 50% mark is going to live. So if we want to go to like the bottom 5% and the top 5% of the distribution is going to be left and right of that point. So what I like to do is go to binomial and use the list function, and then you can easily see, you can calculate lots of values and see where we cross this threshold. So I'm going to start from 15, and enter all the values up to 25, actually, just to be thorough. You want to try and be a bit quicker, you can type in a few, and you can always type in more if you don't quite find the threshold you're looking for. Get 21, 22, 23, 24, and 25. And then we're going to plug in 25 for our n, and a p-value of 0.8. Execute that, and then you see it populates our probability. So we can see for the lower tail, we cross that 5% threshold from 16, which is 4.6%, to 17, which is 10.9%. So the lower end for our critical region is x is less than or equal to 16. And the upper end is where we cross the 95% threshold. You have to be a little bit careful with the upper tail, right? So the probability of less than or equal to 23 is 97%. So if we flip that to go above the top 5%, that's 1 minus, but then that would be 24 or above. So that would mean the top end of the distribution is x is greater of the critical region, sorry, is 24. X is greater than or equal to 24. So that's our critical region for the test. And then it's probably worth writing, actually, these probabilities out. So the probability x is less than or equal to 16, if we go back, is 0.0467. And the probability of x being greater than or equal to 24, we do our 1 minus on 23, is 0.0274. Yeah. Good. So that's our critical region. It says, in his random sample, Talat finds that 18 cars with carbon emissions less than 0.3 grams per kilometer. State the conclusion in context. So 18 does not lie in the critical region. So x equals 18 does not lie in critical region. So therefore, no evidence. It says state in context, so no evidence to suggest proportion of cars with less than 0.3 grams per kilometer has changed. Now it says, Talat now wants to use his random sample of 25 diesel cars registered in 2022 to investigate whether the proportion of diesel cars in England with carbon monoxide emissions more than 0.5 grams per kilometer has changed from the proportion given by the large dataset. Use your large dataset. Give 2 reasons why it is not possible for Talat to do this. So this is where you just have to remember some facts about, like, extreme values of the data, what the data actually is. So one reason they'll accept would be there are no cars exceeding 0.5 grams per kilometer. CO emissions. And then another one is, we know some CO emissions for some diesel cars are missing. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.